missing a few people, we might as well just get going. So, you guys want lights on or lights off? It's kind of tough to see, huh? So let's do lights off. Better? I'll just get my mic real quick. All right. Are we on here? Yeah. Okay. So, hope you guys all had a nice 4th of July and good 4th of July weekend. And let's get back into it, I guess. Oh, let me get this out of the screen real quick. All right. So, today we're going to be talking about objects. And Java is, as you may remember, I said last week, a object-oriented programming language. So, objects are kind of a big deal in Java. It's like it's what the whole language is built around. So, let's get into it. Or at least try. Interesting. Well, she's the keyboard. No, I won't. Okay, here we go. This should work. All right. Actually, first we're going to do a little bit of a recap and a clarification because I think there was some general confusion about a few things, so we'll try to clear that up right now. So the first thing is, why do we write methods? Does anyone have a good answer for this? Why do we write methods? If you recall, last week during lab, we all wrote a program where we wrote an averaging method that averaged 2 numbers. Why did we write this method? Why didn't we just do all this right in the main method? Does anyone have a good answer? It's kind of tricky. The reason is reusability. So if we had just kind of written everything out in the main method, just kind of say, okay, here's a variable whose value is 2.5, and here's another variable whose value is 7.5, and then we added those together and divided by 2, that would be an average, right? And that would work. But let's say we wanted to average 2 different numbers later on in the program. Well, if we took that approach, we'd simply have to write the same lines over again, right? Whereas if we wrote the method, we could simply call the method with new parameters. So not only are you saving time, but you're ensuring that you won't write the same bugs over and over again and have to spend all your time debugging the same code. So I'm going to give you guys kind of a more general example here in a second. But this is really what's powerful about computer science. You can write something once and solve the problem once and have it solved basically forever. So not only you don't have to solve it again, but anyone else that uses your code won't have to solve it again. So you can keep kind of building on top of your own code and other people's work instead of always having to start back at square one. So that's really, really awesome. So let's look at kind of a general example. So, okay, yeah, so this is actually kind of just reiterating what I just said. So this is what you could have written your averaging program as. So it's really like specific to this example, right? It's essentially just saying add 2.5, add 7.5, divide by 2, and then print out the average. So that works, but it's not really that good because you can't reuse your averaging code. Do you guys kind of see where I'm coming from here? So here's kind of a metaphor. So this is a recipe for making cookies. You might not actually want to try it because I just kind of made it up. So it works, right? It's really specific and it works. Go to your oven, turn the temperature dial to blah, 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 this whole thing. But the problem is here, you can see all these steps, like this first one, for instance. Go to your oven, turn the temperature dial 350 degrees, and wait until the oven reaches this temperature. This is something you guys probably know as preheating, right? Everyone who's ever baked anything before has preheated the oven. Well, that isn't really specific to this cookie recipe, right? If you write another recipe for how to bake cake, you're going to have to describe how to preheat an oven, right? So a better way to do this is to essentially create a preheat method. So let's kind of say we do it like this. Now I know this isn't perfectly correct Java. This is kind of something that programmers call pseudocode, which is like a mixture of English and Java, and it's a good way to kind of mock up your programs and kind of design them in your head before you actually get down and dirty into the actual code. But this is the idea. So we got a preheat method, it takes in the temperature, and it describes how to preheat your oven, right? So now, if we did this, now in our recipe we can just kind of say preheat 350. And if you refer to this method, then you'll know what's going on. And now if we did that with all our other steps, we could create a recipe which is the same as the first recipe that looks more like this. So it's a bunch of method calls, right? Preheat, sift, beat egg, mix, ball up, bake. Just like that. So this is, for one, more readable probably, right, than that massive block of English. And in another way, if you wanted to write another recipe that required you to preheat an oven or to beat an egg, you could use these same instructions, right? You wouldn't have to rewrite the whole long instruction every single time. You could just refer to the method. So that's really cool. It saves a lot of time. And let's say oven technology advanced, and you wanted to change your preheat instruction, right? No longer are you turning a dial to 350, maybe you're using a touchpad, and you want to describe that in your method. Well, now you just have to change it in one spot, right? You just have to change it right here. You can just say, instead of turn the temperature dial, use the touchpad or whatever. And that'll be changed for every single recipe that calls that method, right? So that's really cool. You're updating your code just in one spot instead of 1,000 different recipes that all use the preheat method, right? Can you guys kind of see the power of that? So that's the idea. So I hope you can kind of understand a little bit more why we're writing methods now. I know I didn't really do a good job of explaining that last week, so I kind of wanted to emphasize that this week. All right, so the next review note is these things right here. So these are curly braces. And it was kind of a stumbling point for a few people during lab, so I want to kind of really explain exactly what they do. So curly braces are really important. They define the beginning and end of a block of code, like a method or a class, right? So the beginning is defined by the opening curly brace, this one on the left, and the end is defined by the closing curly brace, the one on the right. So anything in between those two braces is considered to be inside a method or inside a class, depending on where it actually lies in the code, right? So if it's inside a method, it'll get executed when that method's called. And they always come in pairs, so for every opening one, there's a closing one. And if there isn't for any reason, then you'll get an error, as maybe you guys saw in lab. Your program won't run. And these can also be nested inside of each other, like you guys also saw. So you have your class brackets, opening and closing, and you have your method brackets, opening and closing, but the method's completely encompassed within the class, right? And this is going to get more and more intense as we start getting into if statements and loops and stuff like that. So you kind of have to really understand exactly what the curly braces mean and be able to realize where your opening and closing brackets are. And as you probably saw, Eclipse kind of manages them for you to some extent. Like if you type an opening bracket and then hit enter, it'll create a closing bracket for you, or a closing brace, however you want to say it. But sometimes if you accidentally delete one, or a number of things can happen where you kind of get lost and you get a little confused. So you have to kind of be on top of it. So that's curly braces. Let's see.
They call the whole thing, they call them class?
Okay, that's exactly what we're getting into later this lecture, but yeah, you'll see later. So the next syntax thing I wanted to talk about is keywords. So maybe during lab last week you realized that some words, when you type them in and then press space, the color would change. And these are keywords. These are basically words that are native to the Java language. So these are words like int, double, char, which you guys I think all realize now are your primitive data types. For instance, an int represents an integer, right? Some more examples of keywords are public void return, which you guys may have typed last week. And then there's kind of like a few other ones that we'll be going through as we go here. And basically the reason I wanted to bring this up is because everything that isn't a keyword, everything that doesn't change color when you type it into Eclipse, is basically a method name or a variable name or a class name that you have created or someone whose library you're using has created. So when you really look at it, there's not too many keywords you're using, and you're using a lot of stuff that you've written yourself and someone else has written. So it's not too much to really memorize, because these words you really just have to kind of understand their meaning as we go. But other than that, it's basically just learning how to create new things on your own, if you see what I'm saying there. Okay, and then here's the big review item I wanted to go over. So, we talked about at the very beginning of last lecture that a program is a list of instructions, right? It's just like a recipe. It's just a step after step after step, right? And so, just like a recipe, the order is really important, right? If you said bake all your ingredients before you said mix all your ingredients, then you would come up with something completely different than what you're actually going for, right? So this is the exact same in programs. But it gets a little bit more complicated, because it isn't necessarily just a step in your main method, just down, 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 right? It gets a little bit, it goes to different places when you have method calls. Like, for instance, we wrote a program last week that had an average method call, right? So it actually kind of jumps around in your code. And this path, the jumping around, is called the flow of control. So, let's see. So, for instance, this is the program you guys all wrote during lab last week. So it starts right here in your main method, right? This is where your flow of control always starts in Java, right here, your main method. And then you declared this variable and you called average. And so your flow of control jumped up here. This method executed, it returned the average back down here. And then you printed out your answer, and then you returned, and your program was done. So it's kind of hard to visualize in this when it's just the code, right? So sometimes it's helpful to draw kind of the flow of control out in a diagram like this. So we started at our main method, always. Always start at your main method. And another point of confusion last week during lab is people kind of wanted to write a couple main methods, but in Java, you're only allowed one main method. And if you think about it, it makes sense. In programming, there's no ambiguity. There can't be anything left up to chance, right? And so if you're always starting your Java program at a main method, there can't be more than one, right? It can't start in more than one place. It has to start in one place. So you only get one main method. So remember that. And Java will help you remember that, because if you write two, it'll give you an error. So now we're in our main method. And if you remember from the code from a slide ago, first thing we did was make a call. We called the average method, right? So now our flow of control shifts from the main method over to the average method. And we have these parameters, this input. So the main method calls the average method with this input. Now the flow of control is over here. This method executes. It calculates a return value. And now it sends our flow of control right back here to the main method. So what return does is says return to the place in code that you were called from as a method. So you call a method from a place in code, right? The main method, called the average method. The average method gets down, it finishes up, it says return to the place in code that I was called from. Well, the average method was called from the main method, so it goes back to the main method. And because we defined a return value, it returns that value to the main method. And then you see we printed it out, and then the main method returned, and when the main method returns, your program is over. So I know when you ran your programs in lab last week, it probably seemed like everything kind of just happened as soon as you hit run, because it was a really short program that didn't take any computational time, but that doesn't mean that things didn't happen in steps. Everything happened in that order. It just happened really, really, really fast, so it seemed like it all just happened instantaneously. But if you slow it down and you realize that the code executes the way you write it, then you realize that it happens in these steps. So this is really helpful to understand when you start writing stuff that's a little bit more complicated. So that's our review. I hope that cleared a few things up. I'm sure everything's not crystal clear now, but we're going to keep learning as we go. And now, onto objects. So, what are objects for? Well, objects model things. Why do you want to model things? Well, think about different computer programs that you use. Maybe think about a video game. Think about a sports video game. A sports video game is really just modeling all kinds of different things. It's modeling players, it's modeling maybe a ball, maybe it's modeling a crowd or a stadium and a field. So it's often in programs, you're going to want to model a bunch of different things. And that doesn't just go for things that are really graphically intensive, like Microsoft Word models things too. Like it models the grammar rules of the English language. It models kind of like how you would write on a piece of paper physically in real life, right? So what are we going to be modeling? We're going to be modeling tangible things, like a car or an athlete. We're going to be modeling conceptual things, like a meeting or a list. And then we're going to be modeling processes, so like shuffling cards or finding a path in a maze. Now, we're going to be sticking to tangible things right now, just for the sake of discussion, because I think it's the easiest to visualize and the easiest to understand. But just know that you can model things that aren't physical, tangible things in the real world as well. So, what are objects made of? What are software objects made of is more important, because real objects are made of all sorts of different things. But software objects have properties and capabilities. So an example of a property would be the color of a car, right? So the object would be the car, the property would be color, and the value could be whatever the color of your actual car is. So if you have a red car, then the color would be red. Now, what's an example of a capability of a car? That could be the ability to accelerate, or the ability to brake, or the ability to turn left, or the ability to turn right, all that kind of good stuff. So properties are defined by variables, right? So that's good, right? We already know about variables. We went over those last week a bit. You guys wrote some in lab, so we already know what those are all about, right? So if properties are variables, what do you think capabilities are? Well, it's our other tool from last week. It's methods. So now we're starting to see kind of the knowledge come full circle, which is nice. It's only the second week, right? So that's pretty good. All right. So how do we create our objects? Our objects, or how do we define our objects, rather? So our objects are defined in a class. Now, a class is basically a file that you're writing into. Like last time we created a class and called it main, right? And it's basically like a text file, and it has the .java extension. These are kind of just like logistical things. So a class is a mold for an object. So if you have a class that models a ball, you can create many instances of that class. So you can create many balls out of that one class. You could have, really big, like green balls, or any color or whatever you want. But the class is basically the mold, and the object is the instance of that class. So you can have many objects created from one single class. This is kind of an important concept that we'll be coming back to. Okay. So that's good. So this is what our classes are going to look like. This is the syntax of our class. So let's break it down. We've got public. So for now, all of our classes are going to be public. Okay? We've got space, class. This is another keyword, right? As you can see by the different color. Or maybe you can't really see with the projector, but I promise you it's a different color. And then you've got space, and then here is our class name. So in this instance, ball. And then we've got our opening curly brace, which corresponds to our closing curly brace down here, right? So everything in between these two braces is a part of our class definition. Pretty simple, right? And then right here is something called our constructor method, which we're about to talk about in a few slides. And so basically this is called ball. This is another name that you create, just like a variable name or a method name. And the convention here is that your class names usually have a first letter, which is uppercase. So this is kind of the reason that we have method and variable names that have a first letter of lowercase, is to be able to easily distinguish between class names and method and variable names. So a little bit of convention there for you, but of course if you can name that anything you wanted as long as there's no spaces in it, just like the other two. Okay, so now we need to introduce instance variables. So what all the variables that you guys wrote last time during lab and we discussed during lecture were called local variables. Now these are variables that basically live and die in a given method. So I don't know if you guys tried it all, but let's say you created a variable in your average method. If you tried to refer to that variable in your main method, Java wouldn't have allowed you to. That variable essentially doesn't exist outside of your average method. So that's all right, but what if you want to have a variable that can be accessed throughout a whole class? Well, you'd use an instance variable. So an instance variable is associated with an object or a class rather than just a single method. So you can reference your instance variables throughout your whole class in any method without a problem. Like I just said. And so this is how you declare an instance variable. Now it should look really familiar except for the first part, right? So this private here is the only thing that's new. And it's pretty easy because all of our instance variables are going to be private. So here's how it goes. Private, space, then we've got a variable type. So int, we're all familiar with ints, right? And then space, and then our variable name. So here's another piece of convention for you. Instance variables should start with an underscore in Java. Again, it doesn't actually mean anything in the code, but it makes it really easy for you to be able to distinguish what variables are instance variables and what variables are local variables. So I highly suggest starting your instance variables with an underscore. Like I said, always private and start with an underscore. So let's create some instance variables. Let's give our first class some instance variables. So this is what we just had, right? And bam, there they are. So our first one is right here. Now, like I said before, we're going to want our instance variables to model properties of our objects, right? So these are some properties that a ball might have: size, color, bounciness. And keep in mind that our types have to correspond to what they're actually going to hold. So our size is going to be an int in this case. Our color is going to be this new thing, which you guys haven't seen before, which is actually our first example of a library object. So this is Java's library object for color. So as long as you have your JDK, which we installed last time, you can use these library objects, and so you guys can all use these color objects, and they're really helpful. So this is our color instance variable, and then here we go. Down here we got our bounciness instance variable, and it's an int. Now this is kind of where the design choices come into play, because you can make bounciness a double, or size a double, or color your own version of a color class. But you have to kind of make decisions. Do you want your size to be able to be a decimal? Do you want your bounciness to be able to be a decimal? It all depends on how you like to code. There's a million ways to code anything. It's just how you like to do it. So there we go. We've declared 3 instance variables for a ball class. Not too confusing. The only thing that's different is we're not actually writing inside any method here, right? We're just writing inside the class. You guys see that? And then we also have to keep in mind that we haven't actually defined these yet, right? We haven't given these a value. We've just declared them. So these don't actually have a usable value yet. They've just been declared. And what we're going to do is declare these within our constructor, which we're going to talk about right now. So constructor method is a method that every class has. And it's got a few rules. First being the method name must be the exact same as the class name. same exact capitalization and spelling and everything like that. The second rule is there's no return values for your constructor method. They just aren't allowed, and it makes sense with how they work, but you're not going to be able to see that yet until next week when we talk about how to invoke a constructor method. But parameters are allowed. So parameters are the things within the parentheses, right? The input. So these are allowed, and they are often used. And so the constructor method is called when a new instance of your object is created. So this, like I said before, you can have multiple instances of an object created from one single class. So this kind of defines what happens when an instance is created. So a really good thing to do within your constructor method is to define your instance variables, right? We declared them, and now we should probably define them, right, within our constructor, so they actually have a value and they can actually be used. Right, that's what I just said. So let's give our ball a constructor. So here are instance variable declarations that we just went over. And here is our new constructor method. So as you can see, it's got its own open curly brace, its own closing brace, and everything in here is within the constructor method. So all of this will be executed when a new instance of ball is created. So can anyone see why we're using these parameters? This is kind of a tricky question, but it'd be pretty impressive if you could figure it out. So like I said, you can create many instances of ball, right? Oh yeah. Yeah, they're single values. And why would we want them to be able to change? Like, why would we want to even have the ability to input different values? Right, because they can be different instances of objects, right? So maybe you want to create a ball that's really big. Or maybe you want to create a ball that's blue. Or maybe you want to create a ball that's really bouncy. Or maybe you want to create a ball that's tiny and doesn't bounce at all and it's green, right? So in order to be able to create different variations of this object, we have these parameters for a constructor, right? So now when you create your new instance, you can tell it, okay, I want this instance to be, medium size, and I want it to be green, and I want it to be really bouncy, right? So that's pretty good. If we didn't have these parameters, then basically every ball would be the same that we created. Do you guys kind of see how that works?
Where is the main method?
Okay, that's another really good question. So the main method is not going to be in this class.
Okay.
And how that's going to work is we're going to have a different class that has a main method that is going to create instances of the ball variable, or of the ball object rather. So that's why we don't need a main method here. But I really like what you're thinking about, because you're probably saying, like, how do you even get any of this stuff to run if there's no main method? Well, you have to have a different class with the main method. So the reason object-oriented programming is so effective and so widely used is that it's just kind of like the same methodology that we went over with how methods make things really easy to build on top of each other. Like, you can write one method and use it again and again and again. Well, you can write one object and use it again and again and again. Like, think about all the video games that use balls, right? You've got like soccer video games, basketball video games, all those different things, and they all use balls, right? So it's kind of crazy to write that same code over and over again when you can just use the same stuff and just kind of tweak it a little bit each time. So what you can do is basically create like a big code base that has a bunch of things that you're going to be using over and over again, and then just have one main method that kind of like creates all those things and gets them interacting with each other. But this is more what we're going to be going over next week, so don't concern yourself too much with how we're actually going to be using these objects yet. Just concern yourself with how we're going to be declaring and defining them for now. So, but that was a really good question, and that's like where this all is headed. So, really good. But that's why we use parameters with our constructor method. Okay. So, if you recall from the slide before, all of our instance variables were given the private keyword, right? So this means that nobody outside of, nothing outside of the object is going to be able to access these instance variables, which is good in a lot of ways because now no one can kind of come in and change the stuff that you don't want them changing, right? But you're probably going to want some things to know about your properties, your instance variables, right? For instance, with this ball, maybe there's something that's going to display the ball to the screen. And that's going to need to know how big the ball is, what color it is, and how bouncy it is, right? So the way we kind of get around this problem is with these accessor methods. So these are going to be methods which return the type of the property that we are concerned with, and they're going to end up returning the instance variable. So this is a really useful pattern in object-oriented programming where you create private instance variables and then you give all of your instance variables an individual accessor method, and then something that needs to know about your instance variable can simply call this method and use the return value to do whatever it needs to do. So if something was going to display your ball, it would call the accessor method on the size, get the size of your ball, and then use that to display the correct size of the ball. So this is what an accessor method looks like. Right down here, right? So again, we're just building on top of ourselves here. So we've got our class declaration up here with its opening and closing brace. We've got all our instance variables here declared, and then we've got our constructor method, which we just went over, which defines all our instance variables based on the parameters. And then right down here, we have the first method that we've written for this class that isn't the constructor. And it's going to be our first accessor method, right? And we're calling it getSize. And it returns type int. So now you're probably kind of starting to see how this would work. So if you are trying to figure out the size of the ball, instead of accessing this variable here, you simply call getSize and then use whatever that returns to represent the size of that ball. It's a pretty nifty technique and it works really well. And you're going to be writing a lot of these types of methods, or this type of method, and these types. But, okay. So what other methods should our ball have? Well, it depends on how we want our ball to behave, right? What other abilities do balls have? That's pretty tricky. Maybe you have like a spin ability or a bounce ability. It's all up to you. You can just code however much or however little you want to make your ball do as many things as you want to be able to do. And so we're going to be writing stuff like this, and we're going to be writing a bunch of accessor methods and constructors and stuff like that, all on Wednesday in lab. So for those of you that weren't here last week, this is how it works. On Wednesday, we've got lab 7 to 8:30. It's right back here. This time, on Wednesdays, you actually need your laptop to be able to do the lab. This lab is going to be a lot different than the first one. So the first one, we basically wrote all our own code from scratch. This one's going to be kind of using some code that I've written and plugging your own code into that. So we're actually going to be seeing like a pretty interesting program. It's going to be kind of like all graphical and a little bit more interesting than the last one that just kind of printed out your own variables. So that's cool. It's really cool. And so this lesson is going to be on the site tonight as well as the PowerPoint. So if you're motivated, review that before lab. And lab should be up by Tuesday afternoon. So if you want to get a head start or just check it out, feel free. And yeah, so that's it. I think we actually finished up a bit early today. All right, yeah, we're actually a fair amount early. So does anyone have any questions? Seeing as that we have all this time. Yeah, what's up, Joe?
You're talking about how the variables of the bounciness, the color.
Yeah.
What how do you judge?
Right. Okay, that's a really good question. And basically, you decide, right? Because it's all stuff that you're creating. So, like an integer value of 10 doesn't really mean anything on its own. But if you say 10 equals 10 pixels right on the screen, then it starts to mean something. Or if you say, if you give all of your size variables, if you consider them all to be feet or something, then that will make them all mean something relative to themselves, right? So that's a really good question, because at first it seems like it's just like size 10. What does that even mean? Well, it means whatever you want it to mean. You can make it so that your smallest ball is size 1 and your biggest one is size 10, or your biggest one is size 1 million and your smallest one is size -40. So it's totally up to you, because you are writing your own code. So you get to decide what values your program is going to interpret as however you want them to do it. So basically, it's just going to be it. How does the program know? Well, you're writing the whole program, right? So all that matters is that you know, and that you interpret all the values the same. So you'll always say, you know, a ball of size 10 is 10 pixels, or a ball of size 10 is 20 pixels, whatever you decide in the beginning. As long as you keep those conventions the same throughout your whole code, then whatever you're trying to accomplish will be accomplished, right? I know it seems kind of like theoretical right now, but once you start actually writing code, you'll see how it manifests itself, how the changes change things. All right, any other questions? No? All right, well, we finished up quite a bit early today, which is interesting because I had the same amount of slides as last time, but I must have been going faster or something. But all right, well, thanks a lot, guys, and I guess I'll see you guys on Wednesday. All right? I actually went to the Cape. Yeah, did you guys serve? Marshall's probably pretty good, right? Yeah, was anyone